So what I'm talking to you today, it's not a plan. This isn't a business model. This isn't something that we're going to be doing in 5 years' time or possibly even 10 years' time. But it's just some options as to a way that we could be producing really nice, high-quality custom yachts in the future. So really, it's kind of like a scoping exercise of technologies used in other industries and how maybe we can start to think about developing them in the marine industry a little bit more. So, very brief introduction of Green Marine. Has anybody here heard of Green Marine before? I can see we've got some subcontractors, so that's all handy. Okay, so basically we're a manufacturer, we're a boat builder. We also manufacture specialist composite parts. In terms of what interests us in manufacture, it's about the most sort of high-end, high-performance, lightweight composite structures. That's our bread and butter. Mostly it's yachts, but it's also wind turbines, prototyping, and various things like that. But for us, it's all about performance. The sort of things that we build, these are our race boats. Obviously, performance-driven. It's about winning races. There's Open 60s, TP52s in the Med. Sure, there's boats there that you guys recognize. America's Cup stuff. Unfortunately, our most interesting America's Cup stuff we're doing at the moment. Definitely not any pictures of that in this, I'm afraid. And also, we've recently been involved in the Volvo project. So for anyone who might not know, Round the World Race, it's gone to one design this time, so they needed 7 identical, robust, high-performance boats for that project, and we were the lead contractor on that. And it taught us some really interesting lessons about kind of repeatability and trying to vaguely productionize what we do, because we're very used to being a kind of cottage industry of custom manufacture, and it let us try to do the same thing a few times in a row. And that not just taught us something about production manufacture, but it gave us some ideas as to how we can recycle ideas and processes even with our custom boats. And more recently, we've been getting into the super yacht sector, even more complex boats. But again, the common thread for all of these things is that they have to be fast and they have to be light. Our company's USP is the way that they perform. And in sailing terms, it's pretty straightforward. You've got to make lightweight structures so that people can have their dishwashers, their air conditioning units, and everything else. And one example of that is that the catamaran that you see, which was my first and most recent project for Green Marine project managing, that boat on its delivery trip did 29.5 knots with half the crew asleep, someone doing the washing up and the tumble dryer running. But the only way that it can be that quick is if we can get the weight out of the structures so that weight can be spent elsewhere. So what is it about custom yacht building that is such a big deal? Why is it different from what everybody else is doing? Why is it different from any other bit of the industry? Well, from our point of view, the first thing is that, I know it's a stupid point, but it's custom. We have no way of amortizing about 80 to 90% of the engineering that we do on any project. And these boats are really complicated. The designers have got all this great 3D CAD, and it is really useful in lots of ways. Unfortunately, it makes it much easier for them to make stuff complicated, which we then have to find a way of building. It does make the boats lighter, but every design that we see has added complexity on it, even when the brief on day one was to make it simpler. So we have to find a way of building that. And in the sector that we're in, with the performance side, there's no real way that we can shortcut the performance. Most of the processes that we try and bring in have a habit of making the boats more expensive, not less expensive, because that is the area that we're driven into. But ultimately, it's kind of strange what we're doing, because on the cost side, we usually only have one client, often one private individual who's actually got to pick up the tab for what we're doing. So despite the incredibly high goals that are set for a project, it's got to be funded, self-funded once over. And if you look at something like the private jet industry, quite a lot of our clients have probably got private jets or certainly access to them. But not many of them have got a custom private jet or even a custom aircraft of any sort, even though at that sort of really high-end product side, people still think in terms of buying something that somebody else has got. And what that allows is that a lot of the investment that goes into these things is then spread out even between 10 aircraft or something like that. But for us, we have to find a way of building these really big, high-tech structures uniquely and to some extent to a price point. Whether people think we're cheap or not is you know, it's a perspective issue. But certainly compared to the cost of an aircraft, compared to the cost of a Formula One car, the resources that we have to build what we have is actually relatively slim compared to the targets for our projects. Really quickly, are there any boat builders here? I can't see any green tabs. Oh, there are boat builders here. Okay, cool. For everybody else, really quickly, the main stages for building a boat. First of all, you've got to construct some kind of a tool, and this shows a pretty straightforward tool with fairly traditional way of doing it. All the frames are actually CNC cut, which you can see there. That gives the sectional shape. Then you're putting down traditional planking, then skinning it to give it a mold surface. That would be a basic way of going about the mold production. Then you have to stick some laminate in it, some skin, something to keep the boat watertight for anyone who's not necessarily in the boat building side of things. And most of what we do is carbon. In this case, it's showing carbon pre-preg, which is basically kind of like, sort of like sellotape, but when you cook it, the glue actually goes into the fibers. But even though we're using a process with materials that are very nice to handle, and all of those guys who are involved in the sort of laminating stage, you can see they're not wearing huge amounts of protective clothing, but it's labor intensive, and again, it's a repeat process, and there's a lot of wastage in terms of backers and things like that you can see lying around. So even in this picture that's been made to make us look terribly efficient and clean, you can instantly see that there's inefficiencies built into the way that we have to build boats at the moment. And once we've given it a skin, then we have to give it some kind of a structure to hold the whole thing together. So how are we going to build boats in the future? Well, something that is quite interesting to us is the concept of automating some of this process. And traditionally, automation has always been something that you think of more in terms of production, doing the same thing over and over again. And that isn't what we do. So the question is, are there technologies emerging out there which actually allow you to do something different every time while saving you a bit of money? And 3D printing is certainly something that is maybe going to open up some opportunities in the future. You can see that if you Google 3D printed boat, this is the first thing that comes up. And although it looks very simple and basic, it floats, it has structure, it supports the weight of the people who are in it, and it was pretty quick for them to knock up. Not quite sure where the hull shape came from, looks a little bit dodgy, but intrinsically it is a boat, and it was cheap to produce, and actually it's relatively light as well for its size. So the way in which we can use these technologies, but on a sort of proper custom high-performance scale, one thing we could look at doing is the way that we produce our tooling. So you saw the sort of classic way that Green Marine produced tooling would be like a direct female mold. Somehow we have to create the shape in which we're going to start sort of sticking in the boat bits. And for us, we're kind of limited on what materials we can use for that, because we've got to be able to build the thing. So quite often it's about wooden frames. We use a lot of CNC, but then it's CNC'd foam blocks that you then have to add laminate onto. And the dream tooling materials for anyone who's been in more sort of production or high accuracy type tooling are things like aluminium or even graphite. And you can imagine that with a 110, 140 foot yacht, you cannot get a block of graphite that big and machine it out and not have spent your entire build budget probably on the day that the raw materials turn up. However, with the possibility of 3D printing, what that allows us to do is lay down these expensive materials, even aluminium, because you can sinter aluminium in the 3D printing process, and you could essentially create very efficient but very high quality mold surfaces with not a lot of wastage of the raw material. So whereas the way that we make molds is kind of deductive engineering, take a big lump of foam, scoop it out with whatever level of technology machine, and then put skins in it. Here, you're more or less adding stuff to a framework. Something else that 3D printing might allow us to do is go back to a sort of more old school version of boat building. So back in the day, if you were building a boat, you'd just put up a few frames, and then you'd start adding your individual planks onto those frames. You never really had a mold. And then in the more advanced stage, maybe those individual planks were made out of balsa wood, which you could then slap some composite skins onto. Now that's largely gone away because of the lightweight cores and stuff that we use, and the performance that's demanded of the boats means we can't really use that kind of classic balsa technology in what we're doing now. However, if you're able to 3D print nice foam core sections, you could stick them on a fairly basic mold, and this guy's making a really nice one-off reproduction of a Aston Martin, I think it is. But you can make those big foam core sections, stick those onto a pretty cheap open-spaced mold, and then laminate directly onto them. So more like the older-fashioned way of kind of direct mail molding, we used to call it. And again, the interesting thing about this is although the scale's not particularly huge, this guy is doing it with something that he just bought in a shop in the high street. Probably a 3D printing box about kind of yay big, and he's just running it off his PC. But he's building an entire car shell out of it. Quite a lot of detail. It's for him, it's basically like a custom item. Maybe not the most efficient way of doing it with smaller pieces. He could probably do with a bigger machine. But the concept is all there as a scalable concept. It seems to work quite well. And you can see the kind of level of detail going in there in terms of nice sort of air vents and things like that. So the quality can be there in this process. Once we've got our nice mold, how about the tape laying bit? Well, we already said that we use pre-preg and we use some quite nice methodologies on that. But at the end of the day, it's still inefficient. It still uses a lot of people. And we still have to consider the way that we lay our molds out and the shapes of them to actually let people physically get in there and do the stuff. So certainly automated tape laying, which is a fairly available technology, albeit currently a very expensive one, is something that would work very well. So you'd create your nice 3D printed mold, you'd bring in your automatic tape layer, and then you'd get the absolute precision and recording of what you're laying in there. And it removes some of the human factor from the actual installation side. And this isn't a particular problem in terms of scalability. Again, big expensive machines, but they're all out there. You could pretty much stick an existing green marine mold under one of these machines, program it up, and it would do the business for you. One thing that's interesting in this is whether the model would be thinking that companies like Green Marine, once we've sold a lot more boats, buy one of these things, or if in the same way that we get big CNC shops to make our big molds for us now, whether there's maybe a big laminating shop down the road, which we send our mold to, and they do this process for us, and then we get back our shell. So it's far more that kind of subcontracted manufacture rather than trying to do it all in-house. Somewhere which is maybe slightly less kind of pie in the sky approach would be on components. Things like rudders, bulkheads have a lot of laminate going into them, often multiple layers of it. Has to be very nicely consolidated, laid down in a very precise way, but we're not talking about giant components. This rudder stock's pretty big. It's for a 50-meter yacht. The laminate's about sort of yay thick on the outside of it. I think there's something like 200 to 300 layers in that laminate stack, and somebody's put down each of those layers manually. It's on a big mandrel to make it a little bit easier, and you can see a guy kind of wrapping the stock with the glass there in a kind of semi-automated sort of way. But for sure, if you could marry that mandrel to a nice aerospace type machine, you can see a way that maybe these things can be knocked out to a very high degree of quality, but they can be a little bit different each time. But it's kind of it could be worth that investment. Again, it's all going to be about the machines. The next stage is once we've got this skin, all of our structures, almost all of our structures tend to be cored. And although I talked a little bit about the foam core and how we might be able to introduce that in a kind of cheaper, more efficient way, what we really like to use is honeycomb cores because they're even lighter and even more high performance. That's what we're about. And you can see the kind of structure, the complexity of the structure in the cores that we use. And you can also see that in a boat, there's typically multiple types of core. You need higher density core in the areas that need to be stronger, lower density core in areas which just need to be lightweight but still solid. And then you have details around edges and things where you need it to be completely solid to make those corners more robust when you add the laminate. And at the moment, that is a real, it's almost like sort of advanced carpentry. Each of those things has to be carefully made and stuck together like a massive jigsaw. And it's time consuming and it's expensive. However, they are just about starting to print honeycomb structures. In fact, I'm not sure, I think there's maybe even some over on the table there that might have come off a 3D printer. These pictures are stolen from Harvard, who are obviously very good at this stuff, it seems. But again, the ability to put those cores down using a machine directly into the mold opens up lots of possibilities, not just in terms of making it more efficient, but it also allows us to properly customize that layout throughout the structure of the boat, something where at the moment you have to choose, and there are these steps, the different colored cores that you saw in the last photo. We could just graduate all of those. And again, the ability to really customize the structure that you're putting into the boat, the load paths that are required. These are all the different patterns of core that can be used. And again, at the moment, you have to kind of choose an area, and all of that area has to be one particular type. And you want to limit the number of different cores that you're using on the boat. If the machine could print those directly into the mold with all of the different densities that you wanted and vary it all evenly, it would be a performance gain as well as an efficiency gain. The next thing we have to do is stick a structure into this. And typically, what you have is some kind of a, that's not very good, some kind of a foam former, which again you stick skins on. So each structure in the boat is almost like its own mini mold or mini hull in itself. Again, that's fairly time consuming. But if, like this very happy chap, you could actually print your structure into the boat, and this is again, the structure that you see inside isn't done by any kind of molding. They've started with a completely bare base, and they've actually built up each of those layers to create all of that ribbing has been done by a machine. So like little layers of glue on top of little layers of glue to create that plastic shell. So from our point of view, that's not going to be a one-stop shop, because we don't build, our structures aren't just made out of one material, and plastic's not really going to cut it. But if the foam that we use for the basis of those structures could be laid in that way, and then we come in either with hand laminators or with our lovely automated machines to add laminate onto it, then that might actually be a viable way of doing more high-performance structures than just a canoe. And you can do some really cool stuff when it gets to 3D printing. So much of what we do is about whether you can physically assemble the parts, whether you can actually get in there and add part B to part C and then laminate over the top of it. And certain materials we can't use because although they're very strong, they're also quite heavy, and you need to use very small amounts of them. And by the time you're using small amounts of them, they're not structurally stiff enough, they're too easily damaged. However, with 3D printing, you can kind of create really amazing 3D shapes. And what's interesting about this is lots of 3D printed bikes out there, lots of titanium frames and things like that. And they're focusing on the kind of production side, creating really cool shapes, but repeatedly. What's interesting about this example is the fact that if you notice, there's no way of adjusting anything on this bike. The idea is that he has a concept, but when you come to him and your legs are a little bit longer and your arms are a little bit shorter, he changes the whole geometry of the thing and then just prints out another one. So there's kind of that idea of taking a kind of a base product, but always making it slightly different and customizing it, but ending up with something that's still vaguely affordable to produce, such that an actual consumer can afford to buy it themselves. And in terms of scalability, again, just very quickly, big 3D printing machines are out there. In China, they're printing houses. This one, I think, is about to print a temple. I believe it's the biggest one in the world, according to Google anyway. Maybe somebody can put me straight on that. But again, it's not so stupid to think that this is something that could be brought into the marine industry. Most of the componentry is there. It's just a question of working out how we fund it and how we use this really expensive machinery constantly to make it worthwhile. And this is a completely stolen computer graphic. I don't know if Julien Boucher happens to be in the audience. I'm afraid I've never met the guy, but this is pinched off his website. So with a big link, please go there, because clearly he's wonderful. But this is some sort of idea as to what this might really look like if we were to do it. So if we produce that kind of shell, this assumes that this is more assuming you build it like an aircraft, that you build your skeleton and then you wrap it. But I think realistically, you'd build the shell first and then put your structure into it. But this is possibly what the future of custom yacht design could get to at some point. And I think it's just a really, really good graphic kind of showing, it just makes it feel a little bit more real rather than just stealing other people's photos. Because this is ultimately what we have to end up with, a carbon-shelled boat with plenty of structure in it. And it's complicated. There's a lot of structure in these things, especially the cruising boats. They've got more rooms, they've got more structure. So to be able to produce all of these very slightly different components in an affordable and fast way would be of huge benefit to our business. The other thing is that it opens up the choice of using completely different sorts of materials. We always at Green Marine shy away from doing anything in metal because you have to start with a lump of metal and then you have to machine bits out of it and throw it all away. And our clients want titanium because that's the only thing that sort of performs roughly along the same lines as carbon fiber. And that's mega expensive to do this stuff with machining. And in fact, we suddenly realized that there was all these grand terms like additive engineering, and we realized, well, that's what we do anyway. We glue just the right little bit of carbon where we want it, and we can't really do that with metals, except that we can now because there's sintering, there's laser sintering. You have like a big load of powder and you just heat it in exactly the right spot and it melts it, and then you add a little 9 and the light lasers go again and they melt a little bit more and it slowly builds it up. I don't know if anyone's ever made an Easter egg before, but it's the same kind of thing. You put your kind of melted chocolate into the mold and then you add another layer and another layer until you've got something that's the shape that you want it to be. So it opens up the chance of getting rid of carbon bulkheads maybe and using titanium ring frames because you can actually build super light structures out of titanium. And again, the reason I chose this example, apart from the copyright-free images, is that the reason that they're doing this on these aircraft is kind of the same reason that we might want to do it for marine engineering. It's a Chinese setup. They want to accelerate the production of their stealth fighter program. It's a much shorter program compared to what they did in the States, and it's much cheaper. The same bulkhead allegedly on an American fighter is something like I think it was $2 million to produce the prototype. This prototype cost $200,000. Not sure if that's dollars or euros, but you kind of get the multiples anyway. So again, it's not so different from what we want to do. We want to do something really complicated, which we don't really have the money to do. So maybe this technology will allow us to kind of punch above our weight for what we're trying to achieve. And what we haven't worked out is future assembly. I mean, you can look at the car industry and there's models like that, but how you customize assembly, haven't got to that bit. So anyone out there want to next year give a talk about how we assemble these things in future, then definitely feel free. That's really the end of it. Thank you very much.